Hi, welcome to my YouTube channel Vaishnav360. Like, share, subscribe, and do not forget to hit the bell icon.
Hey guys, today we are going to do functions in Maths 1A. First of all, what is functions? Function is nothing but a work or a step done by a machine in a common way. But in Maths, a function is a lesson which is mixed with sets. So we will know what is ordered set first, ordered pair first. Ordered pair. Let us take A and B as a set. If A belongs to capital A and B belongs to capital B, then pair A comma B is a ordered pair. For example, we'll take set A 1 comma 2 comma 3 and set B 4 comma 5 comma 6. But A union B is 1 comma 2 comma 3 comma 4 comma 5 and 6. If A is equal to A comma B comma C comma D and B is equals to uh, C D E comma F comma G comma H, then A union B is equal to A B C D E F G and H, right? But if A but if A is equals to A C E and B is equals to B D F, then it is an ordered pair because the answer will be in the order, that is A B C D E F. This would be the answer. That's why it is an ordered pair. So what is ordered pair? We should assume or take two sets A and B, then we should check the condition that A and B is belonging to capital A and capital B. Then this pair is called as ordered pair. Okay, examples for these are here. We'll now know what is an we'll now know what is an Cartesian product. All right, Cartesian product. Let us take two sets A and B as a set. Then we should check the condition, that is A comma B pair slash A belongs to capital A and B belongs to capital B. We should check this condition. Then is called the Cartesian product. Alright. Cartesian product is nothing but we should take two sets and we should check for this condition. If this condition is accepted, then the product is known as Cartesian product. We will do few examples. Okay, first one is a is equal to 1 comma 2 comma 3 comma for b is equals to 4 comma 5 comma 6. So Cartesian product is represented as a into b. This is the way how Cartesian product is denoted. For a and b, it is capital A into capital B. That is the Cartesian product. Now the answer will be first one and these three, 1 comma 4, then 1 comma 5, then 1 comma 6. Then second one, all the three, 2 comma 4, 2 comma 5, 2 comma 6. And then the other one, the third one, and these three, 3 comma 4, 3 comma 5, 3 comma 6. Okay, this will be the answer. I will explain this as we do in multiplication of multiplication. I will take direct example, you check it out. Okay, in mathematics we will do multiplication, right? There is 1 plus 2 and multiplied by 3. Let us take this. The answer will be like this, right? Like this, right? Now here also like this, first one, second one, and then third one. First one, second one, and then third one, like this. For each, like this only. For this answer will be 2 3s are 6 and 3 1s are 3, that is 9. Like this. For this, it is for this Cartesian product answer is this. Okay, let's know the next one. What is relation? What is relation? Okay, what is relation? If A and B are non-empty sets, then any subset of A into B is called relation from A to B. Any relation from A to A is called binary relation on A. Okay, now if A and B are non-empty sets means there is something or other in these both except 0. It is not empty. Actual meaning is it is not empty. There is an algebraic equation or a letter or variable or a number, it may be, but not 0 or null. Okay, then any subset of A into B, that is A Cartesian product B, is called relation from A to B. Any relation from A to A is called binary relation. The relation from set A and again with the same set A is known as binary relation on A. Okay. Now we will take example. The first example of relation is 1 comma 4, 1 comma 5, 1 comma 6. This is the first relation we can say. For example, we should know what is subset, right? Subset. For this, the subsets are 1, 2, 1 comma 2 and not a 0. These are the subset for this. Like this. This is the relation for this. Here, any subset of A slash B, that is A into B Cartesian product B, is called a relation from A to B. This is the relation from A to B. A to B relation. The second relation is, we can take any alphabet or variable as you want, but the set should be same. We should not change the elements in the set. Okay. The second one is 2 comma 4, 3 comma 6 is the second relation. Now we will know what is function. All right, we will know what is function. Function. Let us take A and B as an non-empty sets, and FB a relation from A to B. If for each element A belongs to capital A, then there a exists a unique uh, term known as B belongs to capital B. If this exists in A to B relation from A to B, um, then each element A belongs to A. In this, we will know what is functions now. Let A and B be a non-empty set and F be a relation from A to B. Then for each element A belongs to capital A, this exists and unique B belongs to capital B. So such that then A B pair belongs to F. Then F is called a function. Okay. Or we can call function as mapping also. function from A to B. Okay, it is denoted by f is to A extends to B, and the codomain always has an image known as domain for itself. Okay, now I'll explain it. We should take two A and B as non-empty set and F be the relation from A to B. If for each element A belongs to capital A, then there there will be an invention of a unique set B variable belongs to capital B. Okay, then A comma B belongs to F. Then F is called function from A to B. It is denoted by F is to A extends to B. Now for each codomain there is a domain as an image for itself. Okay, we will discuss the examples, then you will understand what is codomain and domain. Okay, example. Okay, first example is 1 2 3 4 5. These are two sets A and B. This is codomain, and this is domain. Domain is left, codomain is sufficient. This is not a function because there may be more codomains remaining, but there should not be a domain remaining. If a domain is remaining, there should be a codomain which takes the domain as an image. Okay, so this is not a function. We'll see second one. A B 1 2 3 4 5 6 7. Okay, there should not be one image for two codomain elements. Okay, there should not be one image for two codomain elements, but there can be only two images for one codomain element. So this is not a function. We'll take another one. A B 1 2 3 4 5 6. This is an correct function because each codomain has one image domain for each, so it is an function. So now let's talk about the types of functions. Okay, we have we are in now types of functions. We have five types of functions. Five types. Starting with the first type, it is injection. Injection. It is also called as one-to-one function. Okay. The definition is a function f is to a extends to b is called an injection. If distinct elements of a have distinct f image in b. A function f is to a extends to b is called an injection if distinct element of a has distinct f image in b. Distinct element of a, it may be any element but one element, and distinct in f, anything but only one in f as an image in b, then it is known as injection. All right, that is, we can write it as, okay, we will write it as f is to a extends to b is an injection if a1 comma a2 belongs to capital A and a1 is not equal to a2. It implies that if a1 is not equal to f a2. Okay, it's f of a1 and f of a2. Okay, all right. Next one is a1 comma a2 belongs to a and f of a1 is equal to f of a2. It implies that a1 is equal to a2. Okay, let's check out the examples. We should write if these conditions are available in that certain set. Okay, examples. First one is AB 1 2 3 4 5 6. Is this an injection? Yes, absolutely. It is an injection because distinct element in A as an image F in distinct element B. Okay. The second one AB 1 2 3 4 5. Okay. 1 2 3 4 5 6. This is not a function because 1 2 3 4 5 6 is not a function because here two domain elements have one codomain element as its image, but we should not have it. It can be opposite. One domain element can have two codomain images. Okay, like this. 4 5 6 1 2. Then we can have like this, but we cannot have like this. This is correct. Okay, now next, the next one is a b 1 2 3 4 5 6 7. This is an function, injection function, because there may be so many remaining elements in a codomain. We can accept it as a function, but in domain, if there is a single element remaining, it is not called a function. Okay, let's go to the next one, surjection, or surjection is also called as onto function. Okay, now a function f is to a extends to b is called a surjection if the range of f is equal to the codomain of f. That is, if the range is equal to codomain, then we can tell it as it is a surjection function or onto function. We'll take examples. Okay. A, B, 1, 2, 3, 4, 5, 6, 7. This is not a surjection, as the range is 4, 5, 6 and the codomain is 4, 5, 6, 7. Codomain, domain. Okay, range is the number of images the codomain has is known as the range. How many images the codomain has is known as the range. So the images of the codomain is 1, 2, 3. That is 4, 5, 6 is the range. 4, 5, 6 is the range. But codomain is 4, 5, 6, 7. So 7. So codomain is out of range. That's why it is not a function. The second example is A, B, 1, 2, 3, 4, 5. So this is an surjection function, as now B set, that is codomain 4, 5. The range is also 4, 5. That is why it is a onto function or surjection. Okay, now we are heading towards the next function, that is the bijection function. Bijection function is nothing but if f is to a extends to b is both an injection and a surjection, then f is said to be a bijection from A to B. Now, a bijection is nothing but if an injection and surjection is there in this A and B set, if these two conditions are there in these two sets, then it is known as bijection function. Okay. Now examples. First one is A and B. 1 2 3 4 5 6 7. Okay. The first condition, that is injection, is correct, but surjection is wrong. That's why it is not a bijection. The second example, A B 1 2 3 4 5 6. 1 to 1 on 2. These both are correct. You must not confuse in injection and 1 to 1 and surjection onto a function. Okay. You should know both the names. That's why I am writing like this. In these two sets, 1 to 1 and on 2 is correct. These conditions are applied. Then totally it is a bijection. Okay. Now we are going to talk about the constant function. Constant function. Okay. There is nothing here to say. There is a diagram. I will explain it. A B 1 2 3 4 5. Okay. If there is two codomains but only one codomain is used for the three domains as an image, then it is called as a constant function and the answer will be 1 comma 4, 2 comma 4 and 3 comma 4. Okay. Now we are going to talk about identity function. F is to A to A. A to A means same. There are two sets which are non-empty but same elements in it. So the answer here, first the set is 1 comma 2 comma 3. This is an example and the answer is IA, that is identity function. The answer will be 1 comma 1, 2 comma 2 and 3 comma 3. This is the answer for the following. A 1 2 3 1 2 3 is the answer. Okay. Thank you for watching.